अस्सलाम वालेकुम स्टूडेंट्स, क्या हाल है? ठीक ठाक हैं। उम्मीद है आप सब लोग जो है ना बिल्कुल ठीक ठाक होंगे। अल्लाह ताला सबको अपनी हिफ्ज़ व अमान में रखे। करंट सिचुएशन में हम लोग काफ़ी देर के बाद जो है ना वो मिल रहे हैं, तकरीबन 3 महीने के बाद। तो इस कॉन्टेक्स्ट में हमारा जो कोर्स है वो मिड टर्म से पहले जो है ना वो कवर हो चुका था, और मिड टर्म के बाद वाला जो सेक्शन है हम लोगों ने अभी ऑनलाइन टीचिंग में कवर करना है। सो in current situation we have to actually get an overview about the course contents, course details, and the main articles that we have covered so far, and then accordingly we'll move on further for the remaining course related topics and the contents. So before starting, we have a course overview related to the thin film growth and epitaxy. So first of all, I will say that we start from the basic idea of thin films. So the main content of this course actually was divided into 3 main sections. The first section was synthesis. The other section was the growth, and the third section was the characterization. So these are the main 3 sections of thin film growth and epitaxy, the course which is having a course code of 514. So in this context, we have discussed that the synthesis contain the deposition, thin film deposition. And in thin film deposition, we are having different tools which are being used to deposit the thin films, and the part of our course details. So the first one is pulsed laser deposition. Second one is chemical vapor deposition. And the third one is atomic layer deposition. There are also other deposition tools like chemical, physical vapor deposition, other than physical and chemical vapor depositions. So primarily we discussed about these main things that we can briefly overview in this course details. The second thing was the growth of thin films that we started with. The main contents of this growth are the growth mechanisms. And the second one was formation of quantum dots. So in these two main contents in growth parameter, we actually focused on mainly growth mechanisms. Okay, so the third one was the characterizations, and the characterizations were, first thing is the X-ray diffraction. The second one was X-ray photo electron spectroscopy. I just write down the abbreviations of these tools as we are getting out of space over here. So the third one is scanning electron microscopy, that is SCM, and the next one is photoluminescence, that is called as PL, and next is FTIR. And the last one is Raman. So based on the information, this course details these three main sections. We started with the growth mechanisms and the thin film growth parameters, and accordingly we move on for the parameters which are main parts which are mainly contributing towards the thin film growth. So in these growth mechanisms, we actually focused on thin film growth modes. And thin film growth components to effect the epitaxy. So these are actually mainly in the three sections of our course which are concerned about the synthesis, growth, and characterization of the thin films. And among these three sections, we focused on the growth of thin films, and we discussed the growth mechanisms, formation of growth mechanisms. And in growth mechanisms, we further discussed about the growth modes, thin film growth components to affect the epitaxy. So in these three actually components, all the parameters are actually related, which are about concern about the gas kinematics, in gas kinematics, this is concerned about the particles are before the deposition on the substrate. So before deposition, all the parameters concerned with the thermodynamics of the particle, they are discussed in detail, which include the laws of thermodynamics, the state variables, and how the Gibbs free energy can affect the deposition rate and the deposition quality of the particles. And the next one is adsorption, condensation, the first parameter. This then next parameter is the adsorption. So after adsorption, the last parameter is nucleation. So after nucleation, we will actually study the growth of thin films, that is the crystal growth, you can say that. So right now we are at the situation in which we are studying in detail about the nucleation. So that was our main article, main component, which we were actually discussing, and we covered a part of it in our last lectures. So from nucleation, then we move on further to the crystal growth, and then accordingly we move on to the epitaxy of the thin films. So in that way, the growth mechanism and the thin film growth along with its epitaxy, that section will be completed, and then we'll move on to the formation of quantum dots. And by covering this article, formation of quantum dots, we will actually cover this main section that is concerned about the growth. So it will take about you can say that 3 to 4 lectures, or within couple of weeks it will be completed, and then accordingly we move on to the basic synthesis tools, that is the pulse laser deposition or chemical vapor deposition, and then at the last we'll move on to the characterization of the thin films, which are concerned about the X-ray diffraction, mainly used for the structural analysis, that is the crystal growth, how the crystal grows, and what are the plane, what is the orientation of those plane, and is it a polycrystalline structure or a single crystalline structure, so that information can be obtained from the X-ray diffraction. Then X-ray photoelectron spectroscopy, and that is being used to study the compositional analysis or composition of the thin films, that is the elemental concentration or the elemental oxidation states of the material. For example, if we have a doping certain element within the host matrix, then accordingly it will give us the information about the concentration of the doping element within the host matrix. So for example, if I dope manganese in titanium oxide, then the manganese is 5%, then accordingly as XPS will give us the information that what the actual amount has been doped into the host matrix. Then scanning electron microscope, SCM, that is being used to study the morphology of the material, morphological analysis, how the surface looks like, and how it can affect the properties of the thin films. Next one will be the photoluminescence, that will be used to study the optical properties of the material, the concentration of the defects, band gap engineering, how the energy levels are being added into the optical band gap of the thin films, and how they can affect the optical properties of the material. The FTIR, that is concerned about the bond formation. That FTIR and Raman spectroscopy are concerned about the bond formation and the bond carbon bonding which are present into the material, and then accordingly how they can affect the conductivity of the material, the composition of the material, and accordingly at the end the properties of the material. So this was a brief overview of the course contents that we have covered so far, and that we will be actually covering in future.